Okay, so far we were able to solve for any oblique triangle using the sine law. But what if you're given a triangle without a pair, right? So this is I'm going to show you what to do when you don't have a pair. Well, the answer is cosine law, as you can tell. If you're given the following scenarios, we need to use the cosine law, right? So one of the scenarios, let me just took away my notes here. These are the two scenarios, and I just left this blank just in case, right? In case I want to add stuff later. But these are the two scenarios right here. Side angle side or side side side. Actually, I know now why it's blank. We're going to go back up here. Side angle side, just draw one of these triangles. This is the classic oblique triangle. And it's basically saying you're going to have two sides given and the angle in between, right? Angle is sandwiched between sides. Okay, so when you have that, you can tell there's no pair, right, guys? The check marks, look at the check marks. Those will be the information you're provided. There's no way to get a pair out of that, right? You just can't. The other, so this would be SAS. You don't need to remember the letters, by the way, but in the math community, we do that, right? SAS, side angle side. The other one is draw it maybe differently. Draw it like this, just so we don't think they always have to look like that, right? It's when you have side, side, side. So this is your side, side, side. You notice that there's no pair either, right? If it's all sides given, no pair. Can you solve, do you think you can solve a triangle? You can, I can tell you already we're going to be able to solve side, 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 but do you think you can solve angle, angle, angle? Just angles given? The answer is no, you can't do that one. So if I ever throw a trick question at you, I don't know where I'm going to put this. Maybe later, not here, it's too busy here. So here are the formulas, guys. So if you have, I'm going to use at least a red pen for one section. So if you have a red pen or a colored of some sort, it's going to come in handy here because it's going to really bring to light the pattern that you're going to observe. Okay, so if it's an SAS scenario, so let's say we're going to start off with, if it's SAS, chances are we're going to want to solve for this side across here. So watch this. If you're trying to solve for A, it looks like Pythagorean theorem at first. Oh, I'm going to use a red pen for that one, sorry. If you want to solve for A, you got to start like this. A squared is equal to the other two sides. So B squared plus C squared, but this is where it changes, minus 2 times B times C times cosine of the angle across from that side you're trying to find. And that's where I'm using a red pen again. So basically, this is the scenario, guys, where B and C is provided. So side B and C is provided, as well as angle A is provided. So it's like SAS. So you would want to be solving the side across from this angle that's given. Okay, so watch this. If you're trying to solve for side A, you better have angle A across from it. There's that pattern, something across each other, right? Next, I'm just going to give you variations for all of them. So if you wanted to solve for B, let's say, you would start like this. That's the unknown, guys. On the left side is my unknown side, which means that a squared and c squared are provided. You add them, but you go minus 2 times what? You see the pattern? Earlier it was 2 times b times c, right? Now it's going to be 2 times a. Make sure you get these right. Okay? 2 times a times c times cosine of angle B. There you go. Guys, you only need one of these. I'm going to give you 3 versions, but you really only need one of them. Let's say you wanted to solve for side C. Well, that means that you know B squared and A squared. Why did you flip it, Mr. Dixon? Why didn't you go AB? Like you should do it in alphabetical. Well, the answer is it doesn't matter. These are the 2 sides that you're provided with. Minus 2 times B times A times cosine of C. There we go. So that is the pattern I want you to observe. So you'd be solving for A, you'd be solving for B. Here you'd be solving for C. You only need one. You only need to know one version, right? Some students think they have to have all 3 on their study sheet. No, not really. I'm just doing this for you to see the pattern. Okay. All right. What about side, side, side? If you know all the sides, right? You know them all. What is now left to do? You got to start solving for angles. All right. Side, side, side is cosine law, guys. So this is what it's how you're gonna proceed with it. You're gonna say, hey, cosine of angle A, let's say you want to solve for angle A, is going to be equal to B squared plus C squared, watch this, minus A squared. And that is important, that you make sure that if you're solving for angle A, this could be angle X, D, F, it doesn't matter. The side that is across the angle you're trying to find needs to be subtracting, okay? Very important. Then you go divided by 2 times B times C. See these 2 sides? These 2 sides show up again down here. You can probably tell that this formula was derived from this one, right? I just shifted, I moved stuff over, I divided. So this is a variation of this one, right? So if you're on cosine isolated, then right, these 2 need to come over, subtracting and stuff like that. So I'm just shuffling stuff around. For if you wanted to solve for angle B, right, then you would say, well, watch this, guys. This is actually how I will show you to solve. You make a long line like that, and the first number I want you to write down is this one, right? I'm going to make sure that side across from the angle is going to subtract. And then it's going to be what is left? A squared plus C squared, right? A and C are left. And these 2 sides show up in the denominator. See, these formulas are also on your formula sheet, but they're not as pretty. Yeah. And next, cosine of C. I'm going to go faster on this one because I think you know already. You know the drill. Right? Minus C squared. So if C is the one you want, or C is on the end here, that means that it's going to be A squared and B squared. And therefore it's going to be 2 times A times B. And I will say something right under here. This is very important. When given a choice, so put a star. When given a choice, solve for largest angle first. How do you know where the largest angle is going to be? It's going to across the longest side. That's correct. Cosine law, guys, knows the difference between obtuse and acute angles. Sine law doesn't. So cosine is the one you want to use for that. You couldn't use sine law in this case anyways to get you started. Where am I going to do the triple A? I think I'm going to find room later. We're good? So let's put this to use. Let's use this. Okay. I need to tell you something. To start, you're always going to have to choose between sine law and cosine law. To start. As soon as you find something, you can now choose. You can actually switch back and forth because now you know you have a pair. If you use one of these to solve an angle across from the three sides, you actually have a pair now. You can go back to sine law if you'd like. Okay? This is how cool it is. Maybe not for you, but still, I like cosine. I like the sine and cosine law. Okay? Here we go. We're going to do the same as before on page 16. Cosine law to solve for side lengths. So we're going to first deal with side lengths, and that's actually the SAS case. Watch this. Side, angle, side. Right? The angle that is given to you is sandwiched between the two sides. No pair. No pair. Can't use sine law. You cannot use sine. Right? That's another dead giveaway. If you forget, it's like, what is this again? It's like, oh, I have no pair. Can't use sine. It must be cosine law. Okay, so here we go. It just so happens that A is the side that we're trying to find. So we're going to say this. If A is the side we're trying to find, we're going to go A squared is equal to B squared plus C squared minus 2 times B, times C times cosine of A. Whoa, whoa, whoa. Mr. Jackson, what are those dots doing there? Let's multiply. But isn't that a decimal? Well, a decimal is lower. Times is kind of like a between. If you don't like that, let's fix that. I don't like dots, Mr. Jackson. They make me nervous. Okay? So let's just do brackets. Big deal. You gotta learn to do that in life. Okay? So if something doesn't quite look the same, it's like, okay, wait a minute. I think I know. Okay. So A squared, watch this. We're gonna go 7.9 squared plus 5.2 squared minus 2 times the first one here times the second one times cosine of 43 degrees. And here's where having a good calculator is going to make your life so much easier. This is it. This is right here is the where it comes to the test. I told you, I warned you, get a calculator, right? So you go 7.9. I have an x2 button right here, which squares something for me. You might need to use this one, guys. Watch. See this hat button? If you have the hat, or the y to the x, or the x to the y, they get very creative these days. That is your exponent button, right? So I'm going to use the x2. So if you use the hat, you got to go hat 2, like that. That's how you square something. I'm going to go x2 plus 5.2 x2 minus 2 times 7.9. times 5.2 times. Mr. Dixon, are you typing in the whole thing? Yep, that's what I'm doing. Watch this. You should get that. You should get 29.36 repeated. So watch this. You just want A, right? What do you need to do to both sides to get rid of this? Root, yes. So we root that whole thing. I don't want you to round. I just want you to do this and then go dot, dot, dot. That tells me you're using all decimals. And my calculator has a square root button right there. So I'm just going to go square root. I hit equals. And voila, that's it. 5.42. That's standard in this course. It's two decimals minimum, except for money, it's always 2, right? This is what we're in centimeters. That's it. But I will help you out. Some of you are probably like, I can't do that. My calculator doesn't allow me to do that. Okay, here's your answer. Okay. Oof, I made it a bit too cramped, but I can make it work. So 7.9 squared plus 5.2 squared. You do it like that, and then you write down that's 89.45. Let's see if I can make that work. This is 89.45. I want you to use all decimals. It just happens to be 2 decimals, right? Then you go minus, and then you figure out this chunk right here. That is 2 times 7.9 times 5.2. Most of you are just like, no, I like the way you did it before because it works for me. 60.0880. So this is, you need to use at least 4 decimals, right? If you want to do it in steps, use at least 4 decimals because you're going to have to write it down and then type it in and subtract. Okay, so then I go 89.45 minus 60.880. No, wait, 0880. There you go, and then you root that. You still get 5.42 rounded. Okay, so don't use 2 decimals here because then you're going to get a rounding error. Okay. All right. Now I want you to think of this. If you have a red pen, you write that in. That this is now 5.42. Do you have a pair now? Yes, yes, Mr. Dixon, we do. Is this also an SSS now? Yeah, it is. So see, as soon as you solve something, you can choose which path you're going to take. I have a pair now. Have a pair. Okay. We have a pair. Did I say that already? Stop talking about that. So sine of 43 over 5.42 is equal to, which angle do we solve for first? Doesn't matter. We're going to go sine of B. What's across sine of B? Look at your diagram. Side 7.9, right? That's actually the longest side. So it should be bigger. So here we go. Cross, multiply, divide. We're reviewing sine law, guys. Sine of 43 over 5.42. And then you got to go angle B is going to be sine inverse of something that better starts with a 0. Okay. So let's see. Oof, that was close. 0.994 keeps going. Shift sine. That's 83.75. almost a right triangle, but not quite. It says solve the triangle, right? So we're going to find angle C, 180 minus 43 minus 83.75. That's you. Are we doing time-wise? Okay. 53.25. We solve the triangle using both laws. But notice what it says here. At first, you must choose one law. Okay. Okay. I'm going to give you some time. So we're not going to do angles with cosine. It's going to be very similar, but it's actually a bit trickier than sine law. So I want you to go to page 17. And some of you might get in trouble here if your calculator doesn't allow you to type it in one shot. So I actually want you to run into that issue. So all I need you to do for the rest of today's class, tons of time. You can probably finish it and then still have some time to just relax, right? I want you to try both of these. Here you're going to solve for R. Here you're going to solve for Y. I'm going to give you the answers. Here are the answers if you're ready. I'm just going to write them down right here in brackets. So R would be 5.80 kilometers. You got that? And then for B, sorry, the question B, which would be side Y, you get 8.55 centimeters. One of them is going to give you a problem, perhaps. Unless you type it all in one shot like I do, you don't have to worry about that issue. But the little box at the top right kind of tells you what the issue is. I won't talk about it today. I will just come and see you if you're not getting the right answer. And I'm going to say there's no homework, so you're lucky.